What is the required value of the ratio? Line construction, properties of similar triangles, geometric theorem, arithmetic operations, and algebraic processes are used to solve this question. Draw the diameter of the circle. Given that the side length of the inscribed square is 10 centimeters. The distribution of the length values are shown in the figure. The radius, r, of the yellow inscribed semicircle is 5 units. Label points B, C, D, E, and F. Join line B, C, and line E, F. Let angle BCD be equals to θ, which is equals to angle EFD. This is because angles in the same segment are equal. This implies that line BD equals line BF minus line DF, which equals to 2 times a minus 15. Also, triangle BCD is similar to triangle EFD. It follows that line BD divided by line CD equals to line DE divided by line DF, which equals to tan θ. Substitute values. We have that 2 times r minus 15, all divided by 5 equals to 5 divided by 15, which equals to 1 divided by 3. Cross multiply. We have that 3 times, in bracket, 2 times a minus 15, bracket closed, equals 1 times 5, which equals to 5. Open bracket and multiply out. It implies that 6 times r minus 45 equals 5. Solve for r. Hence, 6 times r equals 5 plus 45, which equals to 50. Divide the equation by 6. We have that r equals 50 divided by 6, which equals to 25 divided by 3. Hence, the ratio radius of the yellow semicircle to the radius of the white circumscribed circle equals 5 divided by 1/3 of 25, which equals 3 divided by 5. Therefore, the required ratio, small r to bigger r equals 3 divided by 5.